Hi there. Now in this lecture we are going to look at how to traverse through a double linked list, which means that we are going to visit each element of this double linked list over here and print out their value to the console. So steps to traverse through the double linked list remain the same as we did in single linked list. So we start from the first node and we are continuing until we reach the last node. So here the first thing that we are going to do, we are going to visit the first node and printing out its value. Then we are going to continue to the next node, which is node 2, and printing out its value over here. Then we are going to continue the third node and printing out its value over here. So as you see that the third node's value is 3, so it's printed out to the console. Then we are going to continue to the fourth node and printing out its value over here. Now when we reach over here, we are going to stop over here and the traversal of a double linked list will be finished. Now the algorithm of this traversal will look like this. So we are starting to check head value. So if the head is not equal to null, then in this case we are continuing, otherwise we are going to terminate our algorithm. So if the head is not equal to null, then in this case we are continuing to loop from head to tail, and in each step we are going to print out current node's value to the console. Now as you can see here, when we are printing each node, we were printing out the value of the node to the console, then we are continuing to the next node, and this continues until we reach the last node. Now when we reach the last node, we are going to terminate our algorithm. As you see over here, the steps are same with this single linked list. There also we have visited all nodes and printed out their values to the console, and here also traversal is same. Now based on this logic, let's see how this is working in practice. Now here inside double linked list class, we are going to create another method which is for traversal of double linked list. So I'm going to create our method like this: public void traverse DDL. Then this function will not take any parameter because in this case we are going to visit all nodes of the double linked list and printing out their value to the console. Then the first thing that we are going to do, we are going to check that if head not equal to null, then in this case we are going to traverse through the double linked list. Otherwise we are going to print out to the console saying that linked list does not exist. Now here the first thing that we are going to do, we are going to create a temporary node which will take the value of head. So here the temporary node will be the type of double node and it's going to be named temp node, and we are going to set it to head because in head we have first node's value, so this means that we are going to start from the first node. That's why in this temporary node I am setting head. Now then we are going to loop through the double linked list, so we are going to loop through based on the size that we have created over here. So as you remember, when we are declaring double linked list, we have created size variable over here. So in this size we have the size of double linked list. So this means that based on this size we can traverse through the double linked list nodes, because in this size we have the number of nodes in our double linked list. So that's why I'm going to create our loop like this. So I will start from 0 and it will continue until we reach this size, I less than size, and it will be increased by 1 in each step. Then here we are going to print out the value of the current node to the console. Now we know that the current node is temp node because we are starting from the first node, so we have set it to head. So this means that first it's going to print out to the console the value of first node. So I'm going to print out to the console temp node value. Then I'm going to create if condition in which we are going to put arrow between these nodes over here. So if I is not equal to size minus 1, this means that we have not reached the last node. So when we reach the size minus 1, it means that after this node we don't need to put arrow. That's why I'm putting size minus 1 over here. Then in this case I'm going to print out to the console this arrow over here. So this makes our code more readable. So here we are putting an arrow between the nodes that we are going to print out to the console. Then after doing so, I'm going to go to the next node. So to go to the next node, I'm going to set the temp node dot next. So with this we are going to continue to the next node. Then outside this if condition, I'm going to put else condition. So in the else condition, if head is equal to null, in this case it's going to print out to the console that linked list does not exist. So I'm going to print out to the console the double linked list does not exist. Then outside this if condition, I'm going to print out to the console new line, because in this case this also makes our code more readable. So that's why I'm just going to pass the print statement over here, and I'm going to print out to the console new line character. Then with this we have successfully completed our method. So in this method we are visiting all nodes of the double linked list and printing out their values to the console. Now let's see how this is working in practice. So inside main method we have created our double linked list like this, and we have inserted 3 nodes to this double linked list. So when we are creating a double linked list, we have already had 1 node in our double linked list. So here we have inserted 3 more nodes. So this means that we have 4 nodes over here. Now if I call our traversal method and run our code, now here you see that we have an error in our code. So if I go back, I just forget to put this one over here. Now if I run our code, you will see that our double linked list printed out to the console. So this means that first we are visiting 2, then 3, then 1, then 4. Now here you see that we have inserted 2 as a first node in our double linked list, then 3 as a second node in our double linked list, 1 we had already there, so it becomes the third node of the double linked list, and then 4 we have inserted at the end of double linked list. So with this, as you can see, we are visiting from the first node until we reach the last node. So our traversal method works the way that we want. Now let's see what's the time and space complexity for this method over here. So as always, we are going to start from the first line of this method over here. Now in the first line, we have if condition like this, in which we are checking head value. Now if head not equal to null, then we are continuing to our code. So this if condition over here will take a one-time complexity. Then we are continuing to the next line of code. So in the next line of code, we have created temp node and assigned head value to it. And this one also will take a one-time complexity. Then we have loop like this. So this loop starts from the 0 and it continues until we reach the size of double linked list. So if the size of double linked list is n, so the time complexity for this loop is going to be on. Then inside this loop we are printing out to the console, and we have if condition like this. This printing the temp value to the console takes a one-time complexity, and this if condition also takes a one-time complexity, because here we just have if condition and then we are printing out to the console just this error over here. Then in the next line of code we are setting temp node to the temp next. So this is also assignment statement which is taking a one-time complexity. Then in the else condition we are printing out message to the console saying that the double linked list does not exist. So this one also will take a one-time complexity. And at the end, similarly, printing out new character to the console also takes a one-time complexity. So if we combine all these complexities over here, we get on time complexity, because here on is dominant term. So that's why all non-dominant terms will be eliminated. So the time complexity becomes on. Now the space complexity is O1, because in this case, an extra memory is not required to traverse through the double linked list. So that's why space complexity is O1. Now hopefully everything is clear about this method. So in this lecture we have explained how can we traverse through double linked list, and we have implemented it in practice. So see you in the next lecture.